Good morning, students. This is lesson number 4 of chapter Work and Energy, and today we are going to learn about kinetic energy. Kinetic energy is defined as the energy of a body due to its motion. That is, every moving body possesses kinetic energy. For example, a moving cricket ball possesses kinetic energy, a bullet in motion has kinetic energy, running water has kinetic energy, moving air has kinetic energy. Even a moving hammer possesses kinetic energy. Let us now learn how to derive the formula of kinetic energy.
Kinetic energy. Energy possessed by a body by virtue of its motion is called kinetic energy. For example, a moving train possesses kinetic energy. Let a body of mass m be at rest. Let a force F move it by a distance s and give it a velocity v and produce acceleration a. Work done in moving body W equals F multiplied by S. Since F is equal to ma, W is equal to ma into S equal to m into as. From equation of motion, v square is equal to u square plus 2as. V square is equal to 2as since u is equal to 0, or as is equal to v square by 2. Putting in equation, W is equal to Fs. W is equal to mv square by 2. Kinetic energy of the body, Ke, equals 1 by 2 mv square, where m is mass of the body, v is the velocity of the body. Kinetic energy and momentum. Relation. Let a body of mass m be moving with a velocity v. Then momentum of the body, P, equals m multiplied by v. Kinetic energy of body, Ke, equals 1 by 2 multiplied by mv square, equal to half m square v square by m equals half mv square by m equal to p square by 2m. P square equals 2m Ke. P equals square root of 2m Ke. Some useful results. For same momentum, we have kinetic energy is proportional to 1 by m. Example, when a bullet is fired from a gun, the gun has same momentum backward which the bullet has in forward direction. Law of conservation of momentum. Small m multiplied by small v equals negative capital M capital V, where small m is mass of the bullet and capital M is the mass of the gun. Small v is the velocity of the bullet and capital V is the velocity of the gun. Ke is inversely proportional to m. In this case, the bullet has more kinetic energy than the gun. For same kinetic energy, P is proportional to the square root of m. Discussion of expression. Ke equals 1 by 2 mv square. Kinetic energy of a body is directly proportional to the mass of the body. Ke proportional to m. Doubling the mass will double the kinetic energy. Kinetic energy of the body is directly proportional to the square of velocity of the body. Ke is proportional to v square.
Now let us note down some key points related to kinetic energy. First, kinetic energy is directly proportional to the mass of the body and directly proportional to the square of velocity of the body. If mass is doubled, kinetic energy is doubled, and if the mass is halved, kinetic energy is also halved. If velocity is doubled, kinetic energy increases 4 times, and if the mass is halved, kinetic energy reduces to 1 by 4 of its original value. Second, kinetic energy is always positive. Why? Because mass is always positive. Even if the velocity is negative, square of velocity will be positive. Therefore, kinetic energy is always positive. Third, kinetic energy is a scalar quantity. Fourth, the term speed can be used in place of velocity in the formula for kinetic energy. So, my students, I hope you understood what we studied today about kinetic energy. So, based on that, here is your homework. Thank you. Have a nice day.